This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. All right, here's the second example applying the fundamental identity in trig. So it says find the sine of alpha if the cosine of alpha equals negative 2/5 and alpha is in quadrant 3. All right, first of all, I'm going to solve it without using the identity. Okay, so without the identity, I could just draw a little picture. I know it's in quadrant 3 someplace, so I'm really just going to concentrate on the terminal side here. If the cosine is negative 2/5, I know that the cosine is x over r, right? The cosine is always x over r. R has to be positive, so I could think of that as negative 2 over a 5, for instance, right? So x would have to be negative 2. I can go over 2. Let's say this is negative 2, and I'm just going over to the left 2 and down. Now I know it's really 2 spaces, but just to get the picture, right? And this would have to be 5. So all I know is that alpha ends there. Now that's not necessarily alpha, but that's where it ends. Maybe alpha goes around a bunch of times, etc. So I need to find this side over here, and I could use Pythagorean theorem. Let's call that y. So I know that y squared plus the 2 squared, so y squared plus 4, whether you think of it as 2 squared or negative 2 squared, you're going to get 4, equals 5 squared. So we have y squared is 21. And so in general, y is plus or minus the square root of 21. But I'm over here in quadrant 3, so this is down, right? So I'm going to write, this is my unorthodox way of writing it. Now by looking at the picture, I could tell you what the sine is. The sine is this y value, negative square root of 21 over 5. So I would say the sine of alpha equals negative square root of 21 over 5. So if you like drawing the picture and doing it that way using Pythagorean theorem, you should get that the sine is negative the square root of 21 over 5. All right, let's do this problem using the fundamental identity. All right, so here's our problem. We want to find the sine of alpha if the cosine of alpha is negative 2/5 and alpha is in quadrant 3. Now if alpha is in quadrant 3, okay, so I do have to think about something here. I'm trying to find the sine. I know it's somewhere over here. So the question is the sine positive or negative over here in quadrant 3. You could remember all students take calculus, and you can see the tangent's the one that's positive, so that means the sine should be negative. Or the way I think about it is the y value is negative, sine goes along with the y value. So the sine is going to be negative. So I know that I'm going to have a negative sign. All right, now let's go to the fundamental identity, sine squared alpha, because this works no matter what angle it is, plus cosine squared alpha, whoops, I wrote that wrong, cosine squared alpha equals 1. All right, and what do I know? I know the cosine of alpha. So I have the sine squared alpha plus a negative 2/5 squared equals 1. So the sine squared alpha plus 4/25 equals 1. Now I'm going to have to subtract 4/25 from both sides. So I'm going to write 1 with a common denominator. Since I'm subtracting 4/25, I'm going to write this as 25/25. So the sine squared alpha is 21/25. All right, now if you were just solving this equation and alpha could be anything, then of course you would take the square root and remember to put plus or minus. But because of this particular problem telling us that alpha is in quadrant 3, in this particular value, the sign has to be negative. So when you take the square root, right, you're just going to get the sine of alpha, you're going to have the minus sign. So the square root of the top, square root of 21, square root of the bottom is 5. It's already rationalized, and that's our answer. So we're using the fundamental identity in solving an equation. It's more algebraic looking, right? Now let's look and see how we did it. We got negative square root of 21 over 5. We did it this way. We got negative square root of 21 over 5. Does it matter which way you do it? Absolutely not. Those are two valid ways to find the answer. One, drawing the picture, being careful of your signs, using the Pythagorean theorem. The other, using the fundamental identity. Do it either way, whatever's easiest for you. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.